can you go over an example of a neutralization or double displacement and show which one becomes the ionic salt or precipitate? So let's see what we've got. So first of all, when you have a double displacement, let's see what it is. A double displacement is then when you have a compound, and usually they are both aqueous solutions. So that means that they are both dissolved in water. When you are putting them together, there is an exchange in the solution. So what happens here is that you have usually a metal and a non-metal, metal and non-metal. So when they are together, some of the compounds will be more aggressive than others within compounds. So what will happen? For example, A here is happy with B. However, in solution, A will be more aggressive than C to be part of a bond with D. So you end up here with a new compound, which is AD, and then B that is left alone will go with the C, which is left by itself, and you have CB here. This is what we call a double displacement. Now, if you are thinking of neutralization, when you have a neutralization, what you have, for example, an acid and a base. An acid here, this is hydrochloric acid, and here we have sodium hydroxide. Both of them are dissolved in water, like this. Now, what's interesting here is that when you put them in water, hydrogen is quite aggressive, and we'll go with the hydroxide here, which is OH. And when you have H and OH together, you will create a water molecule. On top of that, you're left with one chlorine and one sodium. When you put them together, you end up with sodium chloride. Now you have water here, and sodium chloride is also dissolved in water, and you have here AQ for aqueous. So this is one type of neutralization. When you have with an acid, you add a base and you end up with this. Now, there's another type of neutralization, and it goes like this. When you have an acid, so hydrochloric acid, and you put an antacid. So here, for example, if you have heartburn, you go to the pharmacy and you use calcium carbonate. When you put them together, what happens? The hydrogen will be quite active, and what it will do, it will get with one oxygen of the carbonate here, you will have two molecules of water. You also have CaCl2 because you have chlorine that are left by itself and calcium here, and you have carbon dioxide. Now here you have an aqueous, you have in water a salt that is dissolved in water, so aqueous, and then you have also carbon dioxide, which will be a gas. Now, what's interesting here, so when we have here NaCl and CaCl2, these are considered salts, like this. So when you have salts, they tend to be, we have, let's see, alkaline metals or alkaline earth metals with usually halogens. So these are what makes salts that are dissolved in water. So that's the first part of your question. So these are what we call ionic salt. So how do they become precipitate? That's a good question. So from what I remember, if you have here an acid and a base, they tend to be creating a salt that is soluble. If you have here an antacid, the salt end up being soluble as well. However, when you have other compounds, let's see if I can have examples right here. So the second part to your question here is what happens to precipitates? So what happens is that when you have a double displacement reaction, so when you have here two aqueous solution that you put together, you have a reaction. What happens is that we have a salt here that is soluble, but it does happen that sometimes you have some compounds or salts that are insoluble in water. So you're going to say, when do we know how that happens? So from what I remember, if you have simple acids like HCl and it creates water and salt, these are soluble. However, when you end up with sometimes compounds that have sulfates and nitrates, then you have to question a little bit what you get. So I'm going to show you here something that is interesting. So when you're doing chemistry, you have what we call a solubility chart. So solubility chart is to determine the solubility of given salts and find a specific information about what they are in different solution. So for example, so here, I'm going to put here the links here. So that's the first one I picked up. If you were to do a search in your textbook or online, you would be able to find other examples. So let's see. So I put it right there. So here, if you have, for example, let's see, I just want to make sure what they mean here. So if it's S, it's soluble. If it's I, it's insoluble. Perfect. So for example, once you are looking at an example, let's see here. So when you are looking at your reactants, here you end up with H plus, Cl minus, Na plus, and OH minus. Here you end up with Ag plus, NO3 minus, K plus, and Cl minus. When they get together, you end up with ions working together. So here I have Ag, so silver and chlorine. Let's see if I have it right here. So if I look at the table right here, I have silver that is on this line right here. And I have at the top here the anions. So here, if I have silver and chlorine, it is an I here. That means it's insoluble. But if you have, for example, sodium and chlorine is soluble. So here, in order to know how if you get a precipitate or not, you have to look at a chart like this. I'm not sure if your teacher will ask you to actually memorize all of those, but I know there's some ideas to keep in mind. Good. So here you can see in blue, aluminum and bromide. So aluminum bromide is soluble. However, silver bromide is insoluble. If you think of the sodium when they are in any of the other anions, it's always soluble. Same thing with potassium. It's always soluble. However, if you take the phosphate, for example, phosphate is always or almost always insoluble, therefore will create a precipitate unless the phosphate is with sodium, potassium, and ammonium here. If you think of the chlorates right here, chlorates is always soluble, sometimes slightly soluble, sometimes more, regardless on the cation it's associated with. So here, the chart will be something important. I remember a long time ago when I was in university, I know there's a song somewhere, if I remember well, to remember which one are soluble or which one are insoluble. If you have a photographic memory, this will be a great way for you to know. So that's basically how you know if you, so first of all, you have your double displacement, you have your equation, you balance your equation, and then you see what you have at the end. So water, it's easy. We have here potassium and the nitrates, if I remember well, NO3, there you go. Anything with potassium is soluble, so that becomes your solution. And here you have to look for Ag, for silver and chlorine, and then you realize that it is a solid. So here reminding, so that S means solid, AQ, aqueous. If it is L in an equation, it's a liquid. And earlier I had CO2, which was a gas. So let's see, Genera, what you've got here. How do you know there would be CO2 that will be in the displacement? So basically, if you have a gas being produced, CO2 at room temperature will create bubbles. If you see bubbles, you have to figure out, is it carbon dioxide, or is it oxygen, or is it hydrogen? You have to look at your reactant, and then you figure out what you have at the end? So that's a good question. So here, this answers that. Time to start singing the song. I know, Zunair, you may have to do a little search for that because I was in university a few decades ago and I totally forgot. But that's something that could be interesting for you. So Zunaira, that's your question, and that was a brilliant question this morning. So let's see. Very good. And I'm going to, when I edit this video, I'm going to put the link to the solubility chart for students. If you've enjoyed this video, please do a thumbs up. If you have any clarification questions, put them in the comments below. I always read them, and I use your comments to answer them indeed and find some ideas for videos as we come along. On this, I'm going to put here a link to another video, and I'll see you there.